So far, we have understood the algorithm as well as pseudocode for implementing the bubble sorting algorithm, right? Now let's go and convert that pseudocode into the programmatic implementation using Java. For that, I am right now inside the Eclipse project Java project that we have created inside the Eclipse. So I will go ahead and create a new class, and I want to put all these sorting related files inside the package sorting. So I'm putting it inside the sorting folder, and the class name I'm putting it as bubble sort. Okay, I'm just adding the main method to clicking on finish. Now let me implement the bubble sorting function here. So I will name the function signature as public static integer array. Let me name the function as bubble sort, and it will take an integer array. In the end, we will also return the sorted array. Let's name the array as ARR. Okay. Now, as part of the pseudocode that we have written, initially we ran a for loop for n number of times, because this, whatever the adjacent element comparison that we are doing, we will have to repeat it for all the elements that are there inside the array that we got, right? So that we will have a sorted array containing n number of elements in the end. So that for loop I'm writing here, I less than arr dot length I plus plus. Now what I will do inside, I will have to compare the two adjacent elements in each and every comparison, right? And I mentioned that I will be starting with index 1. So let me define a loop. Let's say int j equal to 1, j less than array dot length, and j plus plus. Here we will compare the values of j minus 1th index and jth index, right? If the value on the j minus 1th index is greater than the value at the jth index, we will have to swap. So let's compare those values. Array of j minus 1 is greater than array of j, then we will have to swap, right? For swapping, what we will do, let's define a temporary variable. Let's say temp value, let's assign array of j to it. Okay, now let's copy array of j minus 1 equal to, array of j equal to array of j minus 1, and in the end array of j minus 1 equal to temp. So we just swapped. If the value at j minus 1th index is greater than the value at jth index, we will have to swap. The variable name is temp value. Okay, so if we perform the same operation in the end, we will have the sorted array which contains all the values sorted in the ascending order inside the variable ARR only. You remember I mentioned that we will not be creating any additional memory, rather we will be using the bubble sorting algorithm to sort it in the in place in the array that we have been given itself. So whatever the array that we are doing, since we are performing the swapping, we will have the sorted array in the ARR variable only. So simply return ARR. Okay, now let's call the function that we have written and see it actually works. So let me remove this commented code. Let me define an integer array. Let me say it as a, and let's define the values 0, minus 23, 4. In between, let's put one value 20. Okay, if we sort this array in the ascending order, we should get minus 20, 0, 3, 4 and 20. Okay, for that let me call this bubble sort function. Let me pass on the array a. Okay, anyway this bubble sort is returning the sorted array, right? Let's capture that value in the integer array. Let's name the return value as sorted array equal to. Okay, now let's try printing these values so that we are making sure that all the values are sorted in the ascending order. For that, let me just print for int I equal to 0, I less than sorted array dot length I plus plus system dot out dot println of sorted array of I. Okay, Let me right click it and run as Java application. Do you see the output here? Minus 20, 0, 3, 4 and 20. Okay, the values are sorted in ascending order. Okay, in case if you want to implement the bubble sorting algorithm in descending order, like I mentioned, let's just rename the function bubble sort descending order. Let's name the function as ARR. What I mentioned, we will only swap whatever the comparison operations that we did, we will revert it. What do I mean by that? If the value at j-1th index is less than the value at jth index, then we will swap. So what we will do, we will simply change this operation to less than. Similarly, if we try to call the same function bubble sort in descending order, ideally we should get 24, 3, 0 and minus 20. Run as Java application. Do you see? Okay, this is how we actually implement the bubble sorting algorithm in ascending order as well as descending order in Java.